Hello, it's Valentine from Simplistic. And in this video, we're going to take a look at a problem where the magnesium and calcium ions, which are present in seawater, their concentrations are given to you as 0.025 molar and 0.011 molar. And what they're saying is that they can be separated by selective precipitation with potassium hydroxide. And the question is, what minimum OH minus ion triggers the precipitation of the Mg2 plus ion? All right, so the first thing we need to understand what this problem is really saying. Okay, so we need to deconvolute the problem. So what we need to understand is that there are these ions that are present in seawater, Mg2 plus. I'm not going to write the concentration symbol. So you have Mg2 plus and then you have Ca2 plus. And then turns out they're adding KOH. Okay, now KOH is going to generate two types of ions. It's going to generate K plus and OH minus. And turns out both of these positively charged ions are going to complex with the OH minus. Okay, so if magnesium complexes with OH minus, you get MgOH twice, and if calcium complexes with OH minus, you get CaOH twice. Okay, so the question is excuse me, what is the minimum concentration of OH minus that is needed for you to form magnesium hydroxide? We don't care about the calcium hydroxide. The question doesn't require you to figure out calcium hydroxide. Okay, so the way you want to start the problem is you want to take the magnesium hydroxide and then you want to write it in the solid form, and then you want to say, well, if it dissociates, then you're going to have magnesium 2 plus in aqueous form plus 2OH minus in aqueous form. Okay, and the concentration of magnesium that's already present is 0.025 molar. So that's 0.025 molar. Okay, and then the concentration of OH minus, we don't know what that is, so let's call that X. Okay, so KSP, the expression for KSP is going to be Mg2 plus times OH minus concentration raised to the power of 2. Okay, so let's go ahead and plug those values in. So KSP is given to us for MgOH whole twice. So, that is 2.06 times 10 to the negative 13, and that is equal to Mg2 plus is 0.025 times, let's call the OH, let's just keep this OH minus concentration like this. So square, okay? And then we have to just solve for the OH minus ion concentration, which is essentially we take this amount, we divide it by this, and then take the square root of it. So the OH minus ion concentration ends up being 2.9 times 10 to the negative 6 molar. And that's it. That is literally the minimum amount of OH minus needed to precipitate MgOH twice, because that is literally the amount you need out here to get to the value of KSP. Anything over this amount is going to end up forming a precipitate. So that is the minimum amount needed. Okay, I hope that made sense. Thank you for watching.